principle of Cad Cam is really to get from a design through to manufacture as quick as possible. We're taking the CAD data now, we're taking it through CAM software, which will create the cutter paths or the printing paths or whatever it be, whatever type of machine or device we're trying to manufacture or output to. It takes that information and automatically creates programs. Now, on an industrial standpoint, we've got machines now that can move 9 axes at once, which is almost impossible to program. You have to use software to do that. We can program quickly, we take out the problems of things going wrong and misinterpreting data, and we get to manufacturing. We can program more components much quicker. And from education, not many students are expert machinists. They may be good at designing, but then get into becoming expert machinists as well. There just isn't time for that to happen. So it's where the CAM software can take over there. Then we take out that phase where you need to have a lot of knowledge which you don't necessarily have, and again we can get to manufacture. The move to 3D really has got a huge benefit. We can actually put things together on screen, so we can actually take a lot of components and put them together on screen, see how they fit together. And one of the great things about 3D CAD is it's parametric, which means you can just make a change somewhere and it'll propagate to everywhere where that component's used. So if it's used in 10 different machines, it'll propagate down those 10 different machines. And if you've made an error and it causes a misfit somewhere, then it's going to report that for you, which you could never ever achieve with 2D CAD. And of course 3D CAD, although we use it for designing our machines here, it's used across the world for all sorts of things. So cars, of course, will all be designing there. There'll be huge assemblies, aircraft, right down to packaging items. Just anything is done in 3D CAD these days. When it comes to the manufacturing stage, the machines that we manufacture and resell, the 3D CAD really can come from anywhere. We sit very neutral, any school, college, university can use whatever system they want and they can output a standard file. And our challenge then is to take that file and obviously as quickly as possible turn it into a machining path that'll run on the machine, it'll produce the best possible surface finish for the component and do it in the shortest time as well. So the way we do it, we tend to step through in a wizard, we ask 1 or 2 questions per page, go through, and at the end they get a full on-screen 3D simulation of what the machine's actually going to do. And that'll put on there every single machining mark they'll get on the final product. So they could go back and make different decisions and they'll see visually on the screen exactly what's going to happen and what they're going to get. And once they're happy with that, they can commit to going to manufacture and there won't be any surprises on the machine. They'll get what they've seen on screen.